Okay, let's practice how to evaluate a root with any size index. So my first expression is the fourth root of 81. So we have to understand this index 4 is telling us we want to multiply the same number 4 times that would produce the radicand 81. So we know 1 times 1 times 1 times 1 will not work. That's 1. So if we try 2 times 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That doesn't work. So now we'll try 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Therefore, the fourth root of 81 is the number 3. See how simple that is? All right, let's try the next one. We want to do the fifth root of the fraction 1 over 32. We've already spoke about this. When we have a fraction as our radicand, we're doing the fifth root both to the numerator and to the denominator. So we can rewrite it as two different radicals. So the fifth root of 1 is easy. What's the only number you can multiply 5 times to give you 1? That would be 1. The fifth root of 32, we're going to have to think for a minute. Well, we know it's not 1. So the next thing I would try is 2. So I'd say if I take 2 and I multiply it 5 times, because that's what fifth root means, let's see if we can get our 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So yes, if we multiply 2 5 times, we would get 32. Therefore, the fifth root of 32 is 2. So the fifth root of 1 over 32 is the fraction 1/2. All right? Our third expression, we're going to do the sixth root of -1. So again, the index 6 means I want to multiply the same number 6 times to get a -1. Well, obviously, if this is a 1 inside, the only thing we're multiplying is 1. Well, if we write the number 1 6 times, we all know a positive multiplied 6 times would be a positive. So it can't be the number 1. So we're all probably thinking it's -1. Well, if we write -1 6 times and multiply it out, well, if we understand our rules of signs, we all know a negative times a negative makes a positive. We all know a negative times a negative makes a positive. And a negative times a negative makes a positive. So, ladies and gentlemen, there is no way to take a negative number and multiply it 6 times to get at a negative number. Because when you start grouping the negatives together, 2 negatives multiply to make a positive. So this would really be a positive times a positive times a positive, which would not be negative. So we cannot find a number that if you multiply it 6 times would give you -1. Therefore, we cannot do this operation. And when we cannot do this operation, we cannot get an answer. So we say the answer is no real root. Now recall, the index of 6 is an even number, just like a square root is an index of 2, which is an even number. And we learned we cannot square root a negative number. Therefore, you cannot do any root that's even to a negative number. So if this is the fourth root, you cannot do the fourth root of a negative number. Any even root, you cannot evaluate a negative radicand. Our last example is the fifth root of -243. Now our index is 5. That is not even, that is odd. So just like we did a cube root, you could do a cube root of a negative number because cubing is odd. We could do a fifth root of a negative number. So we just got to think of a number that we can multiply 5 times to give us -243. Well, we know it's not 1. 1 multiplied 5 times would be 1. We know it's not 2 because back here when we multiplied 2 5 times we got 32. So I'm trying my next choice, which is 3. So if I multiply 3 5 times, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 would be 243. But I want a negative. So that means, let's see what happens if these were all negative. Well, we know a negative times a negative makes a positive. We know a negative times a negative makes a positive. But then we have this extra negative. So it will work, because a positive times a negative would give us a negative. So you can multiply a negative number 5 times and still get out a negative number. So we would say the fifth root of negative 243 is, in fact, negative 3. Okay, we're going to continue more on roots in the next module. See you then.